Welcome to today's daily video lesson. Today's topic is tables. As with all daily video lessons, feel free to pause the video and solve the question on your own before seeing the solution. Here, we have a single table for a single question. We want to know the fraction of flights for airline A that were delayed. In other words, we're interested in airline A and delayed flights. 861 is going to be in the numerator, so we can eliminate A and D. And the total number of airline A flights that were delayed from is the 2,890. So it's option C. Table questions are also very common to be in STEM question type. That is, there will be a STEM and then 2 or 3 questions about that STEM information. In this case, the STEM would be the things over this blue line. Andrea's recommended daily intake of potassium is 50% greater than that of her 2-year-old brother. A 2-year-old, we find, in the table, is going to need 3,000 milligrams of potassium. Since Andrea does 50% more than that, we can multiply 3,000 by 1.5. This gives us 4,500, and identifying 4,500 milligrams on the table tells us that we have an age range of 9 to 13 years. We want the least possible age, and so the bottom of that is 9. So Andrea, at the least possible age, is 9 years old. The second question to this STEM is this. The recommended daily intake of potassium for an 8-month-old child is what fraction of that recommended for a 2-year-old child? So we simply look at the table for these two numbers. 8th month is going to fall into this category, 700. A 2-year-old child will fall into this category, 3,000. Simplifying gives 7/30 as the fraction. Here is a new STEM question. Again, we have a STEM, and there will be 2 questions about this STEM. The band is composed of freshmen, sophomores, juniors, and seniors. Make a mental note that we only see the juniors and seniors. 30% of the students in the band were juniors. We want to know the total number of students in the band. For this kind of a question, you need to provide your own variable. Let's call the number of students in the band B. Notice that 30%, or 0.3, of the students in the band were juniors. So 0.3 times B is going to be the number of juniors in band, which is 18. Thus, we see that B is just going to be 18 divided by 0.3, which is 60. Here, the number of juniors and seniors in the drama club who walk to school, 25% of them do. This 25% of the juniors and seniors who walk to school represent an eighth of the total number of juniors and seniors who walk to school. We want to know how many juniors and seniors walk to school. Again, we need to provide our own variable. So let's say that the walkers are W. Let's dissect the first sentence. 0.25, which is that 25% of the number of juniors and seniors in drama club. So we're interested not just in juniors, not just in seniors, but in the total in the drama club. These, who walk to school, represent 1/8 of the total number of juniors and seniors who walk to school, which is our chosen variable W. Isolating for W gives 8 times 0.25 times 48. Simplifying this yields 96.